Welcome to another episode of Biology from Jay's House. Woohoo! Okay, today, hopefully you're feeling really good about the circulatory system. You're understanding that the circulatory system carries the three things we need to survive. We need water, put that in your bag. We need oxygen, put that in your bag. We need nutrients, put that in your bag. And your blood takes it everywhere. And that's it. Not only do you need this stuff, but every cell in your body, your heart cells, bone cells, brain cells, liver cells, every cell in your body needs it, and it is your circulatory system that brings it there. So now I'd like to get a little bit deeper, and I'd like to talk about blood types. So I didn't collect homework, I didn't go over homework, but I know what you guys are thinking. Jay sure talks a lot, but hopefully you yelled, what's the point? Let's go and write the date. I believe this is supposed to be the 25th. I don't know. Write down the correct date. I don't remember when we're supposed to do this, but hey, there it is. Okay, skip the line, go all the way left, and do me a favor and write the point. Is that on screen? Just barely. Okay. So we're still talking circulatory system. These notes should follow right after the note about highways and that sort of stuff. So what are the 4 blood types for humans? Different species have different blood types, but humans, we have 4 of them. Technically 8. I know you may be yelling at your screen about 8. What about plus and, MO negative or MO positive? Well, we may or may not get to that. But first, let's figure out what the 4 blood types are, the 4 basic ones. So the 4 blood types, this is one of those times where I'm actually going to give you the note, and then I'm going to answer the point, and then I'm going to take the entire video to explain the answer. So it's a little bugaboo. I'm actually going to leave some space so I can write the answer to the point, because I'm going to do that in just a minute. But first, we should probably figure out what blood type is. Blood type is the 4 types. And those are A by itself, B by itself, AB, which is A and B together, and O. A, B, AB, and O of blood, the 4 types of blood humans can have. There it is. So, if I look at the point, I feel like the answer might be somewhere. What are the 4 types of blood? Well, the 4 types of blood are humans can have. This isn't true for dogs, horses, that kind of stuff. Bloods humans can have are A by itself, B by itself, AB together, and O. That's it. Bam. Hey, class is over. Good. Go home. We're done. Shortest video ever. 4 minutes, and we did a whole class. Not. So what determines this stuff? So what we're going to do is we're going to spend this class period, figuring out why is it A, B, why is it A, B together, and why is it O? Seems like an outlier. A, B, and AB, kind of A by itself, B by itself, and AB together. That kind of makes sense in my head. What's with the O? That seems odd. So pause the video, take the notes, and then unpause. We're back. To understand blood type only is completely defined by 2 things in your blood. The first thing is your red blood cells, the parts of your blood that carry oxygen. blood type is 100% related to this. We'll find out in a minute that plasma also plays a role, but really, it's this that defines it. So turns out the red blood cells come in, they have these little things on the edge called antigens. And what I mean is a red blood cell can have different chemicals, which are called antigens. You don't need to know the word antigen, but red blood cells can have different chemicals on the outside. And I'm just going to start doing that for sake of time. Red blood cells. Okay, so these red blood cells that carry oxygen, that's their whole job. They can have only two different types of antigens. So let's say that one type of antigen, let's say, is little circles. Oh, look at that. So cute. And we're going to say that that is type A. And let's say that the other chemical, now, are they actually circles? No, they're chemicals. They're long necklaces of atoms that you'd study in chemistry. I'm just drawing them as circles. And let's say the next one is like little, I don't know, we'll do diamonds. How about that? Just clearly not circles. And do you think there's just 5? No, your teacher's just lazy and he's not going to draw hundreds of them. So we'll call this type B. So if I pick up a red blood cell and I find out that the chemicals on the outside are these round type A antigens, then it's type A blood. If I grab one of your red blood cells and it has these diamond-shaped type B antigens on the outside, these chemicals are called antigens. If it has these pointy ones, then you have type B blood. I wonder what AB is. Well, my guess is it probably has, a little bit of the A and a little bit of the B. It's not chocolate, it's not vanilla, it's swirl, baby. And we call that type AB. Because it has both antigens. It has the A antigen, it has the B antigen, so it's type AB. And what if you're type O? No antigens. None. Baldy. So type A blood has type A antigens, type B blood has type B antigens, type AB has both A antigens and B antigens, type O have none. And notice how an O looks a lot like a 0? That's probably not random. Whoop, there it is. Okay, hey, you now know the 4 types of blood. We're done. Wait a second, there's probably more. As much as I like an 8.5-minute class, there's probably a little bit more to it if I'm going to wrap a whole class around it. And the answer is, there is. So, let's erase this nonsense and noise and talk about who cares. So, first thing, why do you think we even have blood types? There's a bunch of thoughts about it, but here's my kind of idea. My idea is the number one goal of all organisms is to stay alive. What we love is we like being alive. We like it a lot. And as a species, we would like for a lot of us to be alive so that we hang out on planet Earth, because if you kill all of us, then we don't come back. You kill a couple of us, but but some of us remain and we reproduce, we can repopulate, right? And we see that all the time as conservation efforts bring species that are almost extinct back from the brink and have healthier populations. We really like being alive. And my thought is, if you go way back, before we had science and medicine and all this stuff, when we were living in caves and we weren't even farming yet, what you found out there, that's what you ate. Whether it was running or whether it was growing, that was your diet. And imagine that somebody you really like, a mom, a dad, a brother, a sister, a son, a daughter, gets a deep cut. And a lot of this red stuff comes out. Well, back when we were cave dwellers, if a lot of this red stuff came out, you couldn't go to the emergency room, get patched up, get some more blood thrown in, be good. You most likely were going to die. Sorry, shouldn't have had all the red stuff come out. But let's say that, you're a good human, even if you're a cave dweller, you're still a good human and say, hey, wait, I got an idea. Before they die, when they're still alive, I'm going to come over and I'm going to give them some of my red stuff. There you go. Take my red stuff to replace the red stuff you're losing. And then we'll both stay alive. Well, that totally works in modern day. But back when we were living in caves, what that did was that took one person who was going to die and made it two people who were going to die. And that's bad for the species. So my thoughts are, why do we have blood type? To stop this. To make sure that we didn't give our red stuff to people who are losing their red stuff. Because if you imagine, even in the days of like kings, if the king lost a lot of blood, they would probably just pile a whole bunch of peasants and bleed them all out, trying to save the king, right? And then you have all these humans dying to try to save one. And that's bad for the species. So my thought is that we evolutionarily decided, what if we made this never work? Or just not work very often? What if we had it where most of the time, if you gave your red stuff to somebody else, you both died? Then we wouldn't give red stuff to each other. Also, remember, the red stuff goes everywhere. So if you imagine, not only is it carrying nutrients, water, and oxygen, what about disease? What if it's taking disease also? Then it takes your disease, puts it in them, and takes your disease all over their body. It's terrible. Do not play with red stuff. Don't swap red stuff. Keep red stuff inside. And so what we did was, evolutionarily, we said, what if we had different types of blood? And what if they didn't really mix? What if you could only give blood or receive blood from very specific people under very specific conditions? Then this wouldn't happen. And what would happen is, if this guy over here lost a lot of the red stuff, this guy would say, listen, I would love to give you my red stuff, but most likely we would die, because that's happened pretty much every other time that we've tried this. So I'm sorry, I will sing songs about you and remember you for always, but I'm keeping my red stuff. I believe that's why we have 4 blood types. Is it true? I don't know. I wasn't there. So, how does this work? Now, we understand, hopefully, that the red blood cells come in 4 flavors. There's the A flavor with its cute little round antigens. There's the B flavor with its cute pointy antigens. There's the AB flavor, I just can't make up my mind. Could I have one of each? And then there's the O flavor of, oh, really? I don't get any antigens? And that is the types of blood. But the way I see it is, these look completely interchangeable. If I was losing a lot of this kind of blood and somebody gave me that kind of blood, it seems like it would work out. So this one doesn't have the pointy bits. Who cares? Well, that's when we have to switch from talking about blood type in terms of red blood cells and start thinking about the plasma. So we're switching from talking about the red blood cells, which are down here, the red stuff of your blood, and we're going to switch and start talking about the plasma, the liquid portion of blood. So the next thing I talk about is actually floating around in the liquid portion of your blood. Now, when you donate blood, the only thing they need is they need this stuff, right? When you donate blood, what they do is they separate out the blood, and then they just take the delicious red stuff, and they don't take this. That's how it works. But now we need to talk about that. So I take a blood sample out of myself or out of you. I get all of it. I get all the bits. So now we're going to talk about the plasma portion of the blood. And it turns out that in there, you can have these anti-bits. These are called antibodies. Now, anti-A, I notice if I look at anti-A, it kind of has round edges at the end. And those click on quite perfectly to the round antigens of A. And what they do is if these click together, this no longer carries oxygen. This can no longer do its job. It doesn't do this anymore. It is now useless. Aww. So if this went with A, it would literally make your red blood cells useless. And that's why it doesn't. It goes with B. Ooh, I'm starting to feel like there might be a table that we can draw. Ooh, everybody loves tables. On the red blood cells, you have antigens. Those are the shapes. In your plasma, and this is in the red blood cells, antigens on your red blood cells. And in the plasma, you have antibodies. And that's inside the plasma, the yellow portion of your blood. So anti-A would turn off A, but does it click onto B? Well, let's take a look. Anti-A and B, nope. These are round, that's pointy, these are fine. So these can flow past each other without clicking and turning off. So this is fine. Having an anti-A with B, no problem. But what about an anti-B? Oh no, now it has pointy bits. Now that clicks on perfectly, click. And these little antibodies click onto here and it literally turns the blood off. Doesn't kill it, it just stops it from doing its job. Which means it doesn't get replaced in your bloodstream. This thing flows all around, it just doesn't do its job. It's like, you know, that millennial that moved back into its parents' basement and is waiting for the perfect job that's 6 figures, even though they have limited skills. Yeah, that. It doesn't do its job, but it takes up space. So your body won't replace it, won't put a good, healthy blood cell in there. It'll just do this. And you'll literally not be able to carry enough oxygen. You'll suffocate while you have plenty of blood. So you can't have anti-B with B. But what about anti-B with A? Well, let's take a look. Oh, these are pointy bits. Those are round bits. They don't stick. That means these can flop around each other no problem. And that's why, in type A blood, you'll have anti-B antigens, and it's fine because they don't click. So in type A blood, you have on the red blood cells are type A antigens, and in the plasma, in the liquid portion, are anti-B antibodies. And in type B blood, the red blood cells have type B antigens, and they have anti-A antibodies. And we'll talk about why that matters. What about AB? Well, AB. Wait, anti-A could click right onto that round section right there of AB and turn this whole thing off. So we can't have anti-A with AB because it would turn it off. What about anti-B? Same thing. It's got the pointy bit. This has a pointy bit. These would click together and it would turn off again. Oh, man. And that means if you have AB blood, you cannot have any antibodies because both antibodies could turn you off. So type AB blood does not have type A or type B antibodies, or anti-A or anti-B antibodies, because both would shut it off. But what about type O? Type O blood. Well, let's see. Yeah, there's nothing to click onto. We're cool. What about anti-B? Again, nothing to click onto. We're cool. And that means that type O blood can have A and B because there's nothing to click onto. He's bald. So type O blood has both anti-A and anti-B. Now, there's the chart. If you search the internet and do blood types, this is what you find. But the chart's quite pretty. But what it doesn't explain is, so what? What does that have to do with me giving you red stuff or me getting red stuff from you? And the answer is because when I give blood, I give all the bits. So in my body, not only do I have the red blood cells, platelets and plasma, which we're not, or platelets and white blood cells, which we're not talking about, and the plasma. When all of this is in my body. It's floating around. That's the full postman, and it's floating around everywhere. Now, let's say that I am type, I don't know, we'll say type O, which means in my red blood cells, I have type O blood cells, and in my plasma, I have anti-A and anti-B. Yeah, it totally works. No problem whatsoever. Oh no, I've been mauled by a saber-toothed tiger. I'm losing a lot of red stuff. Oh no, hey, look, that guy over there wants to give me his red stuff. He gives me his type AB blood. Uh-oh. My antibodies, click, turn this off. And now what he's given me is a bunch of millennials that move back into their parents' house and are doing nothing but getting in the way. Yeah, thanks for giving me your red stuff, yo. It's not even doing its job because my antibodies have turned it off. Grrr. So when you receive blood, it's how does the receiving blood affect the antibodies that are in your blood? But what about giving? I'm a giving kind of dude. Let's say that I still have my type O blood with my type anti-A, anti-B antibodies, and I come across somebody with type B blood. So their red blood cells have type B antigens, and that means they have anti-A antibodies in their plasma, right? And that's fine because the round bits don't click onto the pointy bits and we're good. And I come and I say, hey, I'm going to donate blood to you. And they go, oh, okay. I said, but don't worry, I'm smart. I'm not going to give you my plasma because I don't want to hurt you. I'm just going to give you my red blood cells. Now, because I'm type O, it doesn't matter who I give to. It's always going to work because there's absolutely nothing that can turn it off. I don't care if you have anti-A, anti-B, anti-AB. My red blood cells can't be turned off because I'm type O. You're welcome. And that's why they say that type O is the universal giver. If you have type O blood, and I do actually, that I can give to anybody because my red blood cells can't be turned off by any antibodies. So I'm a universal donator. Look at me go. And that's where it really comes into play. What types of blood can go in, right? Where if you're AB, hey, I'll give you my AB blood. Again, click, turns off all the donated blood, and thanks for wasting my time, dude. So that's all I got for you. We already went over what are the 4 types of blood: type A, type B, type AB, type O. And that is completely defined by the antigens that are on your red blood cell. Do you have type A antigens? Do you have type B antigens? Do you have both A and B antigens? Or do you have no antigens? And in your plasma is going to be stuff to turn off other people's blood so that you don't go giving your red stuff to other people. People don't give their red stuff to you unless you're in a hospital and doctors are involved and science happens. So there it is. I'll see you tomorrow for more biology from Jay's house.